Okay, so this is the video for topic number 5, the AC power. And this is the current I built with AC power supply indeed. Small resistor represent the, the resistance in the transmission lines, and of course the load network that has inductors, resistor here in scissors, and this part and this part is going to be in parallel. And finally R3 in scissors with these two. So because this is a AC powers current, we need to tell things in the theta domains, and and we just calculate out the total impedance of the whole load network. That leads us to a power factor, and the power factor is also has a function like this. It represents how the current and the voltage is out of phase. Somehow like the plot here, you can see there's this, because of the out of phase of the two current, the voltage and the current, there is period that one is positive and one is negative, and that is going to cause that the load network in that period is going to behave like a power supply. And then because of that, the current of the whole circuit is going to increase, and increase of the current leads to a higher voltage for the resistance of the transmission lines. That is going to cause a power waste, and that is not what we want, and we want to decrease it as much as possible. So what we're gonna do is we're gonna correct the power factor to 1, which means we're gonna make voltage and power, we're gonna make them in phase again, because we had inductor in the load network, and to think opposite of it is of course we add a capacitor in parallel with the load networks. That cancel out the impact of the inductor part and make the power factors become 1. So the plot is going to be something like this, and this is what we expected for a very high power efficiency. And with something like this, because the capacitor can also supply current half of the time when like there's a need, and so it actually decreased the current in the circuit and because of that the voltage gonna decrease, and the energy waste in the transmission lines is going to be decreased. And if we put, and we use the inverse of the impact to find out the value of the capacitor we need to add into the circuit. So we add in the capacitor here. You can see Z load is now equal to this things in parallel with this part that represents the capacitor. And we finally got things like this, and this is what we want, and this shows that the value of it is correct. And then is the simulation and analysis. This part here is to find the current in the theta domain of the load network, and with this part and with the voltage of the R4, we can find the voltage, the source voltage for this part using the voltage dividers. And by so we can find the complex power of the thing, and the real part of it is like the real power is it's like the average power, and the imaginary part for it is like reactive power. It's like how the load network is like the average rate of the load network to like stored energy. And yeah, then by so we can find that this is the output of the simulation is actually matches what we got from Maple. This is a very good thing for us because it shows us that this is what we calculate, what we build here is correct. The function is matches the circuit we built here, and with the and you can see the plot here is actually the same thing. It's actually the same with this one. So there is a power factor that not equal to 0, not equal to 1, sorry. And with the capacitor, it's finally gonna be like in phase. And this is the current in physical. As we can see here, this part, the red line is like the AC power supply is where the black one is the ground, and we follow the red one, we into here, and we first go to this part. This is R3. If you remember, R3 is here. You can see from the one without the capacitor is somewhere here. Yeah. And then with the orange cable here, it like runs to like the two inductors, which is parallel and in series with two resistor. And when we connect them together with the green one, that is the parallel part that has the inductor and the resistor in series. Remember, it's like this part. And what's next is going to be R4. R4 is with this green soft cable, and this part is R4, and which connect to R4 is the ground, just same like as this. And I think that's pretty much it for the video, because the hand CAD is not working, so I don't have that part, the measurement or the like discussion about that. But yeah, this part is actually I think this is quite